your parents and you're based on them, basically, like you're part of them. Well, related conditionals are related to the original conditional. So they are statements that are based on a given conditional. Oops, upon. So they're related. So we have our original statement is our conditional statement, which is our if-then statement. Right? So if P, then Q. The symbols for that was P implies Q. And for an example, I'm just going to say if the measure of angle A is equal to 35 degrees, then angle A is acute. Okay. So that's our given conditional statement. So given. Now we can write related conditionals based on that. We have a converse, an inverse, and a contrapositive. Anybody wearing Converse? It makes it really useful. No? Okay. A converse occurs when you exchange the hypothesis and conclusion. Okay, everybody's familiar with Converse tennis shoes, right? And you know where the star is? It's on the inside of the shoe. Like right on the inside of your ankle, which to me doesn't actually make a lot of sense. It seems to me like the star should be on the outside of the shoe. Well, but that'll help you to remember that a Converse flips things around. The Converse shoe has the star flipped to the inside, so a Converse statement flips the sentence. So instead of being if P then Q, we are if Q then P. So we're flipped. Okay? So it goes Q to P. So we just turn it around. So if angle A is acute, then the measure of angle A equals 35 degrees. So all we do is we take the front and the back and we switch them. And then the next thing we have is an inverse, which negates them both. So we use words like don't, not, etc. We add those words to it. So it's if not P, then not Q. So if the measure of angle A does not equal, you guys, if I put a slash through it, it means doesn't equal 35 degrees, then angle A is not acute. Okay, so we can flip with the converse, just like the shoes have the star flipped to the inside. The inverse is to make things negative. And the word inverse means opposite. So if you can make that connection, opposite being negative, inverse is opposite. And then we have something called the contrapositive. And contrapositive does both. It flips and negates. So if not Q, then, sorry, I should say then not P. So if angle A is not acute, then the measure of angle A does not equal 35 degrees. So we have our original statement, our conditional, our converse flips it, our inverse negates it, and the contrapositive does both. Is logically equivalent, okay? Equivalent means equal, right? But logically equivalent, it doesn't exactly mean equal, but it means they have the same truth value. So for things that are logically equivalent, basically we're saying they're essentially the same because they have the same truth value. So it essentially has two S's. When you talk about related conditionals, the conditional, the original statement, and the contrapositive okay, so the conditional and the contrapositive are always logically equivalent, which means if the conditional is true, the contrapositive is true automatically. If the conditional is false, the contrapositive is false automatically. And so I'm going to step back for just 1 second. If we go to our angles, if angle A is 35 degrees, it's acute. This is true, correct? You guys all agree? True? If I go to the contrapositive, if angle A is not acute, then its measure is not 35 degrees. That's also true, because if you're not acute, you're not going to be that small. You're going to be much, larger than 90. So, or 90 or larger. So these are both true. If we talk about the inverse and the converse, the inverse and the converse are always logically equivalent. Okay, so they're either both true or they're both false. When we go back for just 1 second, I'll come back. If the angle A is acute, then the measure is 35. No, that's a false statement, right? Because we could be 40, or we could be 20, or we could be 4, or anything basically up to 89.9 something. So this is false. If angle A is not 35, then it's not acute. Well, maybe it's not 35. Maybe it's 34. It's still acute, right? So this is also false. Logically equivalent. Sometimes. Sometimes you get a situation where all 4 versions will be logically equivalent. There's no, conditional and contrapositive are always logically equivalent. Inverse and converse are always logically equivalent. There is not a set relationship between these two sets. Sometimes they're the same, sometimes they're not. You can't say they're always opposite or they're always the same. It just depends. For example, I could say if the measure of angle A is 90, then angle A is a right angle. Okay? The converse, or sorry, the inverse of that is if angle A is not 90, then angle A is not a right angle. So that was the inverse. And then I could do the converse, which is if angle A is a right angle, then angle A is 90. And then the contrapositive, which is if angle A is not a right angle, then the measure of angle A is not 90. That's the contrapositive. Now when we look at this one, if angle A is 90, it's a right angle, that's true. If it's not 90, then it's not a right angle, true, true, true. So sometimes they can all be the same. They can all be true or they can all be false. That's situational though. Thing that happens, right, when the conditional and the converse so when the conditional and the converse both have the same truth and they're both true, okay, you get a really fun thing called a biconditional. And bi meaning two, so this means that you're true both directions, right? Because if your converse is the flipped, so if you're true going forward and you're also true going backwards, you're biconditional. So if we look at our conditional was it if angle A, so if the measure of angle A equals 90, then angle A is a right angle, true. And then our converse, which was if angle A is a right angle, then the measure of angle A is 90 degrees. Both true. So we can write a biconditional statement. And biconditionals use the phrase if and only if, which you can actually abbreviate as an if with two F's. IFF. If and only if. So what I can say is if the measure, or sorry, not if, the measure of angle A equals 90 degrees if and only if angle A is a right angle. That's my biconditional statement. So measure of angle A is 90 degrees if and only if angle A is a right angle, which that tells me that if angle A is 90, then it's a right angle, or if it's a right angle, then it's 90. That goes both directions. Inverse, or sorry, conditional and converse are both true. We're going to write the converse, inverse, and contrapositive of the following true statement, but first we have to write it in conditional format. So we have to start with the if-then. So I'm going to start with the conditional. Okay. If an animal is a lion, then it is a cat that can roar. Okay, so P to Q. We can write our converse, which just like the shoes, it's flipped. So if an animal is a cat that can roar, then it a lion. Inverse, not P, not Q. So we're just same order as the original, but putting the not in there. So, oops. If an animal is not a lion, then it is not a cat that can roar. And
what does that mean, CT?
Where?
Upon the first.
Here?
If animals is in line, then CT is a cat.
It. That's an I. And finally, the last one we have is our contrapositive, which is backwards and negative. So if an animal is not a cat that can roar, then it is not a lion. Okay? So if you're a lion, are you a cat that can roar?
Yes.
Yes, so that's true. If you're a cat that can roar, are you a lion? Not necessarily, right? Because you could be a tiger or a panther or a leopard or anything, right? If you're not a lion, are you not a cat that can roar? Well, you could still not be a lion, but you might be a tiger or leopard or whatever. That's false, right? Because I might not be a lion, but I could still be a cat that could roar. Does that make sense? And then if I am not a cat that can roar, I'm not a lion.
Yeah.
That's true, right? Because if I'm not a cat that can roar, then I can't be a lion. I'm more likely like a zebra or something, right?